In today's video, we're going to look at how we can find unknown angles or sides in right-angled triangles. The first thing you need to know is that you can normally tell when a triangle is a right-angled triangle because it will have this little square in one of the corners which tells us that it's 90 degrees, so a right angle. The second thing to know is that this side opposite the right angle is always called the hypotenuse, which we represent with the letter H, and this will always be the longest of the three sides. Now, how we label the other two sides changes depending on which angle we're interested in finding. For example, if we were interested in finding this angle in the bottom right, which would label as x, then this side, which is opposite x, would be called the opposite, which we represent with the letter O, and then this side next to our x angle, or in other words adjacent to it, would be called the adjacent, so we label it with the letter A. On the other hand, if we had this other triangle and we were interested in finding this top angle instead, then the longest side will still be the hypotenuse as always, but the bottom side would be the opposite O because it's opposite the angle we're trying to find, and then this left side would be the adjacent. Now, to help us work out the unknown angles and sides, we're going to be using three different equations: sine x equals opposite over hypotenuse, cosine x equals adjacent over hypotenuse, and tangent x equals opposite over adjacent. Unfortunately, you have to remember all of these off by heart, but what's easier is just to remember the phrase SOH CAH TOA, and then you can work out the equations from that. For example, if we look at SO, the S stands for sine x, the O stands for opposite, and the H stands for hypotenuse, so we know that sine x equals opposite over hypotenuse. Meanwhile, for CAH, the C stands for cosine x, the A stands for adjacent, and the H stands for hypotenuse, and the same rules apply to TOA. T for tangent, O for opposite, and A for adjacent. If it helps, you can write SOH CAH TOA as S equals O over H, C equals over H, and T equals O over A, which makes it a bit easier to spot the equations. To see how these equations work in practice, though, let's have a look at this question where we've got to work out the value of the unknown angle x. Now, whenever you get a question like this, the first thing that you want to do is label all of the sides. So this one is the hypotenuse because it's the longest side and opposite the right angle. The bottom one is the adjacent because it's next to our angle that we're trying to find, and this one is the opposite because it's opposite our angle x. The next thing to do is note which sides you know the length of, and in this case we know the length of the opposite, which is 15, and the adjacent, which is 11, but we don't know how long the hypotenuse is, and we don't need to find out either. So next we need to look at the three equations and find which one we can use with the information that we've been given. If we start with sine x equals opposite over hypotenuse, we can't use this one because we don't know the length of the hypotenuse, and if you look at cosine x equals adjacent over hypotenuse, we've got the same problem again. This leaves us with the tangent x equals opposite over adjacent equation, then which we can use because we do know what the opposite and the adjacent lengths are. So if we rewrite this out plugging in the values that we know, we get tangent x equals 15 the opposite over 11 the adjacent. Now, solving this is actually a bit weird because sine, cosine, and tangent are all functions rather than numbers, and this means that we can't just divide both sides by tangent to get x by itself. Instead, we have to use the inverse tangent function, which is tangent to the power of -1, and on your calculator you can probably find it by pressing the shift button and then pressing the tangent button. When we apply this to both sides, we end up with x by itself on the left and tangent to the power of -1 of whatever we had on the right, so in our case tangent to the power of -1 of 15 over 11, and then all you have to do is put that into your calculator, and you should get 53.7, and remember, because we're working out the angle of x, it's 53.7 degrees, and that's it, that's our answer. Let's have a go at one more. So in this question, they're asking us to calculate the length of PQ, which is this length here. So we can go ahead and put a question mark on there because that's the unknown one that we're trying to find. Then, like before, we're going to want to label our triangle. So this side we're looking for is the hypotenuse. This bottom side of 20 centimeters is the adjacent. This side on the right is the opposite, and this angle of 35 degrees is our x. This time it's the opposite that we don't really care about because we haven't been given its value, and we're not trying to find it. So we need to find the equation that has the adjacent and the hypotenuse in it, which will be cosine x equals adjacent over hypotenuse. Because we're looking for the hypotenuse, though, we're going to have to rearrange the equation to get the hypotenuse by itself, which we can do by multiplying both sides by the hypotenuse and then dividing both sides by cosine x to get hypotenuse equals adjacent over cosine x. Then the last thing we need to do is plug the numbers in, so the hypotenuse is 20 over cosine 35, which, if you put it into your calculator, should give you 24 centimeters. One last thing to mention is that if you ever get a calculator error in this sort of question, it could be because you didn't close the bracket after the angle. So just remember that after writing cosine 35, you have to put this closing bracket. If you haven't heard yet, you can find all of our videos on our website.